Set 4, directions for question 16 to 20. The diagram below shows a network of roads connecting the starting point X and the two endpoints Y and Z. The other points P, Q, R, S, T, and U, these are called nodes. The path or the route between two directly connecting nodes, as in S to U, or a node and X, Y, or Z. So these are called roads, or these are called roads. So all roads are unidirectional as indicated by the arrows in the given network. So the arrow point, the arrowhead, it tells us from which particular starting point or the node you're moving over to the next node or the end point. So this is a question based on routes and networks. In such questions, primarily you need to figure out how many cases or how many paths you can have from one point to the other. So let's look at the questions to get an idea what is the level of this set. So the first question has got definite options. So going to be an easy question. Next question has again definite options, going to be easy. Next one is theta, so maybe easy or a little difficult depending upon how many cases we need to form because it starts with if. Next question, again it starts with if, but we do have definite options and one with the all of the above. So we have to be careful. Okay. For question number 19. And question number 20, if and with a theta, so might be easy or maximum moderate. So let's solve. So we need to first of all find out how many possible routes are there from points starting point X to the two endpoints Y and Z, right? So we need to find out all the paths. So let's start with X and let's deal with the right hand side path. So X to Y, we can go directly. The next could be if we go from X to P and then P to Q to Y. And next one is if we start from X, go to P and then R to Y. The next one is if we take X and RQ is to be brought in. So if we take P and then R and instead of going directly to Y, let's go QY. Let's do the left hand side now. So we can go from X to Z directly, we can't go. So we will have to go at least via one node. So XUZ, the first one. The next one is, let's take XSUZ. The next one, let's take XTUZ. And the next one is by going through all the three nodes, XSTUZ. XSTUZ. So these are the four left hand side paths and the four right hand, a total of 8 paths we have. Let's move over to the question and see what are going to be the options and how do we solve them. Question number 16. Find the total number of possible routes from the starting point, that is X, to the endpoints Y and Z. So we just found out that there are 8. So there are 8 possible routes. Question number 17. If a node is shut down, you cannot make any route going to or from that node. Which node should be shut down to reduce the number of possible routes from X to Y and Z by the maximum possible extent? So in other words, we need to find out that particular node, when it shuts down, the number of possible routes out of these 8, it gets reduced by the maximum amount. So of course we can't shut down X, right? We can't shut down Y and Z because those are not the nodes. So the nodes we can shut down are P, Q, R, S, T, and U. So if we pay a little attention, P is there in 3 of the paths. Q is there in 2 paths. R is there in 2 of them. S is there in 2 of them. T is there in 2 of them. while U is there in 1, 2, 3, 4, all 4 of them on the left hand side. So if we happen to shut down U, none of these 4 routes can be taken. So the answer is going to be D, that is the node U. If it shuts down, the number of routes from starting to end point will diminish by the maximum extent. Question number 18. If the time taken to traverse 2 directly connected nodes is the same, then what is the maximum number of routes from X to Y and Z that take the same total amount to traverse? So in other words, the question is asking that out of these 8 routes, how many routes have the same number of letters? Because if we have same number of letters, we are going to have the same number of nodes, and the time taken to traverse through those routes will be same. So XY is just a 2-letter, XYZ is a 3-letter word, XPQY is a 4, this one is a 5, while this one is also a 5. So we can say that there are 4 such routes, right? The maximum number of routes is 4 from X to Y or X to Z that take the same total time to traverse. So the answer is going to be 4. Question number 19. If it takes 10 minutes to travel any road and an additional 5 minutes of waiting time is imposed for every node other than X, Y, and Z, then which of the following cannot be a valid travel time between the start and end time? So let's pick up X, Y. So from X to Y, we are not allowed to count the wait time at X and Y. So it will take only 10 minutes. So 10 minutes can be a valid travel time. The question asked is cannot. So we have to pay attention to that. Let's now take the 3-letter word or just having one node, the route. So XUZ is going to take 10 minutes for XU. U stoppage time is 5 minutes. And then from U to Z, it will take another 10 minutes for that path. So it will take a total of 25 minutes. So that means 25 minutes is also a valid travel time. Let's now take a 4-letter word. Let's take XPQY or XSUZ. So let's take XPQY. So X to P, P to Q, and Q to Y, each one is going to take 10 minutes into 3. That will be a total of 30 minutes. And then we will have stop at P and Q, these 2 nodes. So that will be 5-minute stoppages for 2 such nodes. So it will be a 10-minute stop. So a total of 40 minutes is what this will take. So that means 10, 25, and 40, these all are valid travel time. So the question asked is cannot be a valid travel time. So the answer is going to be none of the above. Question number 20. If it takes 8 minutes to travel on any road and an additional 4 minutes of waiting time is imposed for every node other than X, Y, and Z, then find the total time in minutes to travel from X to Y and X to Z, traversing every node exactly once. So if we need to start from X and need to reach, let's say, Z by going through STU, all the 3 nodes exactly once, that means we need to have a path that consists X as the first letter, Z as the last letter, and STU in between them, which turns out to be this. And the path is going to be X to S, S to T, T to U, and U to Z. In the same way, if we have to go from X towards Y such that we cross through PQR, we have this one, XPRQY path. So since both the paths have same number of letters X and Y or Z at the end points and the starting point and 3 nodes in between them, so for each one of them, the time taken to travel will be, let's say, XP, PR, RQ, and QY. That is going to be 8 minutes per path into 4. That is going to give us 32 minutes. and then stoppages at P, R, and Q. That's a 4-minute stop. So that will be 4 minutes into 3. So that is going to give us 12 minutes. A total of 44 minutes we will have for each of the parts. So 44 minutes for this, 44 minutes for this. The question asked is total time. So we need to add them. We will have a total of 88 minutes. So the path from X towards Y such that it traverses every node exactly once is X to P, P to R, R to Q, and then Q to Y. So the answer is 88.